This is Lesson 2, Part 1, Firewall Fundamentals, corresponding to Chapter 2. The learning objectives are to describe the fundamental functions performed by firewalls. The key concepts are the types, features, and functions of firewalls, essential TCP/IP characteristics, software-based and hardware-based firewall solutions, filtering and port control strategies and functions, and home firewalls and placement. So what is a firewall? It's a network device, network traffic control device or service. It enforces network security policy. It protects the network against external attacks. It establishes control over the network traffic. It prevents connections from unauthorized sources to protected network systems, services, and resources. An analogy to a firewall is a bouncer at a nightclub with a guest list that defines specific names or types of individuals allowed in or specifically prohibited from the club. What a firewall cannot do. A firewall is not an authentication system. It is not a remote access server. It cannot see the contents of encrypted traffic. It is not a malicious code scanner. And it cannot protect against threats from removable media. There are several types of firewalls: multi-homed, screening, stateless, stateful, and application proxy. Here you see a multi-homed firewall on a network. This multi-home firewall has three different faces: one to the internet, one to a private local area network, and one to the demilitarized zone, which contains various different servers. A bastion host firewall sits between the internet and a switch or router that runs the entire network. Stateless inspection. In this type of firewall, it maintains no state tables for active connections. Frames are treated individually rather than collectively, and filtering decisions are based on static addresses and port numbers. In stateful inspection, it maintains records of active connections. It does this to determine whether or not packets are part of existing sessions. It passes or allow and blocks or deny decisions. Those decisions are based on packets belonging to legitimate connection streams. Once a session, it looks for packets that don't belong to authorized sessions. Advanced stateful firewalls track session endpoints and then retains additional state details such as acknowledgement numbers and sequence numbers. Connectionless traffic is not stateful, and therefore firewall state management does not apply. There are some advantages of stateful filtering. Keeping the state observes network connections between points. Most session-oriented protocols use random source ports. State tracking adjusts and adapts to real-time traffic conditions. State tracking watches end-to-end traffic streams, session-oriented startup and teardown. State tracking treats packets collectively, start to finish, rather than individually. And state tracking has high operational overhead because it has robust rule configurations. Stateful firewalls provide efficient packet inspection. Existing connections are checked against the state table. The computationally intensive firewall filter lookups are avoided. Lack of stateful record keeping could result in breaking of legitimate connections. Arbitrary source ports to well-known service destinations can get dropped. Firewall filtering types and strategies. Stateful and stateless inspection, tracking connection states to separate legitimate from questionable traffic. Stateful multi-layer inspection, it inspects the packet headers and payloads. Offers a complete view of the entire 7-layer OSI protocol stack. Examines setup, state, and teardown of connection-oriented protocols. Proxy servers respond to connection requests between clients and servers. Separates and isolates external and internal network endpoints. Circuit proxy, circuit-level firewalls, monitors TCP handshakes to track sessions. Application proxy filters by protocol content to enforce safe application behavior. Network address translation, or NAT, separates and isolates external and internal network endpoints. It can map several internal addresses to a common external address. In this way, it can hide the internal address from the untrusted internet. Ingress and egress filtering monitors and filters directional inbound and outbound traffic. Packet filtering examines network protocol headers and parameters. Static packet filtering or stateless packet filtering uses a fixed set of rules to filter network traffic. Dynamic packet filtering, which is stateful, watches connection states to filter the traffic. This operates at the lowest OSI protocol layers, generally the data link layer, which are switches, and the network layer, which are routers. Content filtering focuses on network protocol payloads. It intercepts and investigates packet content before it enters or leaves the network. It concentrates on domain names, URLs, file names, and extensions. It administratively blocks unauthorized download resources and websites, and operates at the higher OSI protocol layers. Here we have the TCP/IP networking and OSI reference models, the two stacks, which we discussed in Chapter 1, and therefore we're not going to go over them again, other than I will mention that the next slide discusses various protocols that run at the application layer of the TCP/IP protocol stack, the transport layer, the internet layer, and the network interface, and so we will discuss those further. The TCP/IP protocol suite, here the application layer, which is at the highest level, includes the following applications protocols: the domain name system, DNS, the dynamic host configuration protocol, DHCP, the hypertext transfer protocol, HTTP, the telenetwork or telnet, which is rarely used today, and file transfer protocol, FTP. The transport layer includes the transmission control protocol, TCP, and the user datagram protocol, UDP. The internet layer includes the internet protocol, which is IP, IPsec, internet control message protocol, ICMP, address resolution protocol, ARP, and internet group management protocol, IGMP. The network interface is the serial line internet protocol, or SLIP, and the purchasing power parity, or PPP. Here we see the structure of a packet: the source port, the upper left-hand set of bits, the destination port, a sequence number, acknowledgement number. At the very bottom is the data, which of course has a variable length. A packet moves through the protocol stack. As data moves from a software application for transmission over the network, it traverses the layers of the protocol stack from top to bottom. As each layer receives data from the layer above it, that data becomes the payload with a layer-specific header. Down at the data link layer, where Ethernet resides, the data receives a footer as well. This process is known as encapsulation. The inverse, known as de-encapsulation, occurs when a network communication is received. As this process takes place, the data set being manipulated receives unique names depending upon the layer it traverses. The encapsulation process of adding headers and a footer at the data link layer enables data exchange between layers on different systems. This is known as peer-to-peer communications. The content of a header includes information to be processed by the corresponding layer on the receiving end of a network link. The content of the headers is the greatest concern and focus of a firewall. Application proxy firewalls and stateful inspection firewalls can also examine the headers and the payload content of layers 5 through 7. This is the end of Part 1.